Two previous videos detailed the construction of this mock-up cardboard compartment in preparation for fabricating a final metal or plastic version. After coming across an inspirational video, my plans are now to see if I can convert this cardboard mock-up into a final version for permanent use. I'll see if I can make that happen next. I'm going to first do some testing by glassing a scrap piece of cardboard since I haven't used resin in quite a while. I sort of remember how it flowed when pouring and what the drying process was like, but just to be sure, I'd rather do some test glassing to see if it's what I remember. I'll fill this plastic container up partially with the sanding resin and add about 10 drops of catalyst. The resin is pretty thick, so I have to be sure to mix the catalyst in thoroughly. I want to do 4 different tests on the painted side of the cardboard. The first pour is the resin mix directly onto the cardboard. The second pour is resin mix with fiberglass cloth on the cardboard. At this point, I'm thinning out the resin mix with acetone. There was no predefined thinning mixture to follow, so I added about 2 teaspoons of acetone to the resin mix that was left in the cup. The third pour is the thinned resin mix directly onto the cardboard. The fourth pour is the thinned resin mix with fiberglass cloth on the cardboard. I'll let this sit for 24 hours and see how things look tomorrow. I've decided to review the resin after 12 hours. The thick resin seems well adhered to the painted surface and has hardened to a durable finish. The resin thinned using acetone still seems a little soft and pliable. Some of the edges has lifted from the cardboard while drying. Even pressing the cloth that has lifted during drying demonstrates how there is no adhesion to the cardboard just beneath it. I also want to check how well the resin has soaked into the cardboard. I know the painted surface is a huge barrier, so at worst, I'm expecting the resin to simply peel off the surface of the cardboard due to it not being able to soak into the cardboard through the paint. The thick resin did seem to have good adhesion even with the paint. I tried digging under the resin with a knife and it held well. I cut out a section of the resin and it was more pliable than I expected, but I'm thinking it's because this was just the resin layer. If it had soaked into the cardboard, the stiffness and durability should be a lot better, especially when combined with the fiberglass cloth, which should add a bit more stiffness and strength. On the other hand, the resin thinned with acetone adhered terribly. I could peel it off with my hand. The only reason it stuck to the cardboard was because it was still a little tacky between the dried resin and the cardboard. I'm probably not pursuing thinning the resin for this project, but it was a useful experiment to find out how terrible it is. I'm now going to do a similar test on the unpainted or bare side of the cardboard. This test should produce better results. What I'm hoping occurs is that the resin soaks into the corrugated cardboard and turns it into a structure of corrugated resin. The only thing I'm worried about, but won't see it in this test, is if covering a large area with resin will cause warping. As I pour the resin onto the cardboard, dark patches begin to appear where the resin is quickly soaking into the bare cardboard. This is a good sign, and an important thing I have to check after the resin dries is how deep into the cardboard the resin has penetrated. Even halfway would be great, since that would be a pretty thick layer of hardened resin. Taking a closer look just after the pour, the dark patches on the cardboard are looking really good. The cloth side seems to have soaked into the cardboard better than the side without, but the side without is still mostly dark and should be fine. I'll see how things look once the resin cures. 24 hours have passed and it looks like the hardened resin has done a good job at soaking into the cardboard, but I'll cut into the cardboard shortly to see if that's what actually happened. I want to cut through the layers of cardboard and also the fiberglass, but I don't want to cut directly into the fiberglass to avoid it cracking. I'll flip the cardboard over to cut from the cardboard side instead, which I think will help prevent the fiberglass from cracking as I cut through the layers. I didn't plan to do this, but I thought it might be good to know how well the fiberglass will stand up to being banged around. The hammering didn't do any visible damage to the fiberglass with or without cloth. Something I found that makes me worry is that I was able to peel off the glass cloth from the cardboard easier than I'd like. I think it's something I can solve, but I need to do one more test that involves a couple of additional steps. So what I did on this test is poke holes in the cardboard so the resin could flow deeper into the cardboard through the holes. I also sanded the surface of the cardboard because although it doesn't look like it, I'm not sure if the cardboard is actually coated with something which could prevent absorption and adhesion. 12 hours should be enough time to review how this test went. Cutting through the cardboard is harder, and I can tell the resin did penetrate below the surface. Off camera I attempted to peel the resin from the cardboard, and though I succeeded, it was a lot harder to do than in the previous test. My conclusion is, when glassing the compartment, I'll have to prep it first by sanding and puncturing the entire surface. I'll also be using fiberglass cloth for additional stiffness and durability. The sanding process is meant to prepare the cardboard surface for glassing by removing anything that could prevent the resin from adhering, like this patch of glue. The edge is where most of the glue is, since that is what holds the side panel cardboard to the perimeter cardboard. I'm using 120 grit sandpaper and will only prep the smaller upper half of the compartment for now. Once I get the hang of working on this side, I can flip the compartment over and work on the larger half. Like the test pieces, I'll be sanding the flat cardboard to be sure any surface coatings are removed. The goop glue that has to be sanded off is pretty tough and thick in some places, so I'll have to use a razor to cut the thicker parts off to make sanding easier. One thing I'm not sure of is where the goop glue did not get into the seam at the edge of the side panel. I'm hoping that even if I sand away all the glue on the surface, there will still be enough glue in the seam to hold the compartment together. This is a tool I made by drilling a hole through a stick and hammering a nail into the hole. Having a handle for the nail will make puncturing holes in the cardboard a lot easier. I'm not poking the holes in the direction or shape of any sort of pattern. As long as they're not too close together or too far apart, I think the result should turn out as it did on the test pieces. There are quite a few holes to poke, but the nail with the handle is definitely helping to make this task easier. I'm also doing a row of holes around the side of that half, just to be sure the resin penetrates the side as well. All the sanding and holes are done, and it didn't take very long. The sanding was a bit of work, but luckily the tank is kinda small. Because I'm only glassing one half of the compartment, I'm going to tape off the edge so the poured resin won't drip past the tape. It'll probably run off the edge a little, but it won't get on the mold or lower half of the compartment. What I'm doing is sliding the upper compartment half up and leaving it like that while I tape all the edges around that half. The mold within is getting in the way, but I'll slide the compartment to a place where I can tape the edge. Once I'm done, I can push the two compartment halves back together and it should be ready for glassing. There's a lot of fumes from the resin, so I am wearing a mask. A lot of times people use a squeegee to apply resin, but I'm using a paintbrush instead. I'm not going to pour the resin on because it's such a small area. The paintbrush makes it easier to apply a thin, even coat over the top and sides of the compartment. I don't have to worry about streaks left behind from the paintbrush because the resin is very runny and will even itself out right away. One thing I'm doing before leaving the compartment to dry is sliding it up slightly away from the top of the mold. If any resin may have seeped inside the compartment, I don't want the compartment to adhere to the mold. I do want to keep it on the mold though, so it'll hold the shape I want while the resin dries. Earlier in the drying process, I removed the tape from the compartment and remounted it back on the mold so it won't lose its shape while still drying. The items on the compartment are to weigh it down to keep it firmly pressed into the shape of the mold. It's actually been about 2 days now. I had forgotten resin does need to sit for a while before it'll harden completely. When working on surfboards, we used to leave the resin to dry for about a week after the final coat. The edges still do seem a little rubbery to the touch, though not tacky anymore, so I will leave it for a week before sanding. The compartment has been sitting for a little more than a week. I'm going to do a light sanding, just enough to give the next coat of resin something to stick to, but also to round off corners and sharp edges. I felt it would be safer to do the sanding while the compartment was on the mold so that the mold could provide support for the still slightly fragile sides. There were some areas where the resin had built up a thick layer, so sanding took a little longer in these areas. I have to remember to spread the resin out a little more evenly, as well as scrape off the excess that builds up on the edges. I'm thinking of using fiberglass cloth on the next outside layer, but I'm a little nervous because this coat will be poured on and I hope I can keep the resin under control. I'm also thinking about adding pigment to the resin, most likely black. The pigment will go in the cloth layer and the final top layer, so that I'll have some thickness in the resin to allow for sanding and polishing. The first thing I want to do is lay out some aluminum foil on the table to protect it from the resin that'll be poured. Newspaper won't work because the resin will easily soak through it and stick to the table along with the paper, so I have to use something completely non-absorbent. Plastic would have been another good option. I'm also prepping the mold for this glassing. A lot more resin is involved, so I have to keep it from dripping onto the mold. I'm taping the mold's perimeter from under the edge of the compartment down to where the mold touches the table. The excess tape along the edge closest to the table can be wrapped under the mold. Finally, I'm raising the mold off the table by attaching 2 pieces of wood under the mold. If the mold had rested directly on the table, I didn't want the resin to somehow seep between the table and tape and still get onto the mold. Lifting the mold off the table and adding 1 more strip of tape around the perimeter should cause the resin to run down the tape, drip onto the table, and not have any chance of getting onto the mold. Prepping the cloth for glassing is pretty simple. I'll cut the rough shape of what I need, leaving a little overhang past the edge of the compartment. It would have been easier if I could leave a lot of overhang because the weight of the excess glass cloth would help to keep the cloth pulled down tight over the edges of the compartment. I couldn't do that here because of the risk of the cloth adhering to the tape along with the compartment. An important point to keep in mind when glassing is to work fast. I have a good 5 minutes to get the cloth saturated with resin and brushed or squeegeed flat. The instructions state I have 10 minutes, but I think in the 10 minutes the resin will already be in a gel state and no longer workable. I mixed a little more than an ounce of resin and added 14 drops of catalyst. The instructions state 10 drops per ounce of resin, so the 14 drops should be about right. For applying the resin, I do need to pour the resin on to get the entire compartment glassed as quickly as possible. Notice that as I spread the resin with the brush, if I push down too hard with the brush, the cloth will move. It's a good idea to avoid doing this. Light strokes works best. As mentioned, the edge of the compartment where the cloth folds over the side is the area I have to focus on the most. It's where the cloth will most likely lift up and leave an air bubble if I don't pay attention to the edges while the resin hardens. In panning over the still drying resin, it looks like the edges turned out okay. I don't see any signs of air bubbles from the cloth lifting up from being folded over the edge. On the other hand, I do see air bubbles where the resin could not seep into the holes of the corrugated cardboard. Something strange that occurred is looking closely at the top, the resin near the edge seems to have run off the sides, leaving a puddle of resin in the intersection of the flat surface. I'd seen this earlier and tried to brush it out, but for some reason it still ended up that way. The compartment will obviously be stuck to the tape wrapped around the mold, so the tools shown here were used to break it free from the mold. I didn't capture the cutting process on video, but the scissors was used for cutting through hanging strips of fiberglass stuck to the tape. The side cutter was used for fiberglass too thick for the scissors to cut through. Once all the fiberglass was cut to separate the compartment from the tape, a strip of cardboard was used as a spatula to separate the edge of the compartment from the tape. Even after all the cutting and prying, lifting the compartment off of the mold had its issues. A small amount of resin got through some of the cracks in the seams and adhered the compartment to the mold. Luckily, it wasn't a lot of resin, so pulling hard enough worked for getting the compartment separated. In hindsight, I'll try painter's tape to seal up the inside corner of the compartment. The excess fiberglass on the edge of the compartment is delicate, so I had to make this jig to accurately trim it. The block of wood is at the right height to rest the compartment on while trimming. The drill is on a flat surface that I hope will keep it steady and level. What I want to do is trim the fiberglass off but leave the cardboard edge untouched. Right now I'm having to hold the drill with one hand and the compartment with the other. A while later I eventually started holding the drill with my foot, which made it a lot easier to trim the compartment more accurately. I later figured out how to press the compartment against the cutting wheel lightly enough to where the drill didn't move around even without me holding it. It allowed me to hold the compartment with two hands, which made the trimming go a lot faster and more accurately, leaving a really nice edge on the compartment when I was done. I did the sanding off camera because it's the same process as I did earlier. I sanded away the rough imperfections, the high spots, and made sure to sand the entire surface to give the next coat of resin something to stick to. There is one thing that's different though, and that's the cloth. I have to be sure not to sand down into the cloth layer since it's what's providing the strength now. Basically, sand everything down as much as possible, just don't sand down too far into the cloth layer. I ended up with some visible uneven spots, but that's just the nature of making this project out of cardboard. Corrugated cardboard is quite bumpy and not a totally flat surface to begin with. I'm glassing the inside of the compartment next, and to get the best possible results, I'm removing the top layer of cardboard. By removing this painted layer, the resin can soak into the cardboard more easily, creating a strong bond between the cloth and cardboard. Depending on the type of cardboard used, removing a single layer of cardboard could be easier on some than on others. The other option to peeling it off like I'm doing is to use a sander to sand it off. The results of sanding would actually be smoother, but would take a lot more time. I'll prep the inside of the compartment by laying out the cloth. I do this to make sure the cloth edge is lined up as best as possible with the edge of the compartment. I'll also tuck the corners in, first using my fingers, then using the paintbrush. Getting the cloth in place accurately, leaving no need for readjustment while pouring the resin, makes the glassing process go much smoother. The resin mixture is about an ounce in the container, to which I added 10 drops of catalyst. I'm trying to use slightly less catalyst out of curiosity how it will affect the curing process. Same as the outside, I'll pour the resin and spread it around over the cloth using the paintbrush. Since this is the inside of the compartment, I'm not as worried about the visual appearance as much as I was for the outside. My only word of caution for this step is when doing the sides. Brushing the sides tends to pull the cloth upwards, which in turn pulls the cloth away from the corner, creating an air pocket. Brushing the sides with the corner tip of the brush helps prevent this, followed up by also poking the cloth back into the corner with the tip of the brush to make sure there were no air pockets. Towards the end of this clip, some noticeable air pockets formed on the flat section. I could not see this at the angle I had been standing. I did see this later when inspecting the compartment off camera and fixed most of them. Once the resin dried, I trimmed the edges again. I did have to sand the sides smooth and lay down one more coat of resin on just the sides to fill in some gaps that appeared where the cloth lifted. Because I still have some cutting and drilling to do for mounting brackets, I'm not finishing the outside until I complete the second half of the compartment and can then figure out where the mounting brackets will go. I'll complete the second half in the same way but off camera and be back to do the mounting brackets. Here are both of the fully glassed halves of the compartment, still missing some painting and decorating I'll do sometime in the future. Here's a visual comparison of my current battery in the old and new compartment. I still need to add the frame mounting standoffs in the new one, but I plan to make them a lot smaller than the ones in the original compartment. The first modification I'll work on is a way to mount one of the halves to the frame. After contemplating different mounting ideas, I decided to stick with using the original mounting tabs on the frame, but I want to modify them so they're a lot shorter. Using my drill with the grinding wheel, I'll cut away the sides of each tab and leave only the vertical piece in place. I've always felt these tabs were way too big, so now is my chance to cut them to a more reasonable size. This cutting process is taking a lot longer than I thought it would. I'm not sure if it's the type of cutting wheel I have or if the RPM on my drill is too slow. I'm not in a rush, but it would be nice to have been able to move a little quicker. As you can see, I did put some packing tape on the frame to protect it from the metal grindings as well as accidental slips of my grinding wheel. I'll get this first tab on video and do the rest off camera. Most of the cutting will be done using the grinding wheel, but getting that finished look will be done using my burr set and the file. Here's the 3 completed tabs ready for mounting the larger half of the compartment. The tabs and frame are made of steel, so at some point I will have to repaint them to avoid rusting. I'll also have to remove this mounting tab used for the chain guard because it's obstructing some of the space that the compartment will occupy. For me, removing the mounting tab is not a tough choice. I've never used the chain guard and had removed it on day 1 of owning this Jetson. Removing this tab wasn't the easiest, but what I was more worried about was the grinder biting into the metal and accidentally scratching the paint. I'll be painting this frame in the future, but I just don't want to add too many additional scratches along the way. Now that I can begin working on fitting the compartment into place, the first thing to do is mark where the frame mounting tabs line up with the edge of the compartment. These marks are where I'll need to cut into the compartment. It'll be hard to make these marks directly on the compartment, so I'm using this strip of cardboard. It's been cut to the same depth as the compartment. Looking at the area where the compartment will go, the only thing that could be an obstruction are the cranks and chainring. I'll place the cardboard in a position where the end of it has a small gap between it and the nearest obstruction. In this case, the chainring bolts would be the closest obstacle to the back of the compartment. I'll mark on the cardboard where the back of the frame tab lines up with it. This mark is the measurement I need for making the same cut for all the compartment cutouts. Using a pretty good ruler, I measured the mark to be at 2 3/32 of an inch. To transfer this measurement to the compartment, I'm using this woodworking square. It has holes in it that line up with measurements down to increments of 64ths of an inch. The holes are to stick a pencil through when marking desired measurements. In this case, the red bar of the square rests against the back of the compartment and the pencil lead will go through the 2 3/32 inch hole on the ruler. I just need to slide the ruler back and forth to make a line parallel to the back of the compartment. Since this is a square, the edge of the ruler is used to extend perpendicular lines that intersect with the marks made on the compartment edge earlier. I don't have a good way to hold the compartment in place while cutting, so I have it rested up against a couple of heavy items. The footage of me working on the compartment cutouts is not the entire process, but each cutout is almost identical, so how one of them is done is the same for all 3. Holding the compartment while cutting was one difficulty I had, but a bigger one was my drill-mounted Dremel cutter. I have the cutter mounted on a standard handheld cordless drill, and the drill chuck is almost the same size as the cutter. While cutting, I have to hold the chuck away from the compartment to avoid it scraping, but in doing so, the cutter is now cutting at an angle. It can be fixed with a file afterwards, and the cutout is small, but it did add a small amount of additional work. The cutouts came out pretty decent. I like that they didn't take away from the strength of the compartment, considering they're pretty big. The frame tabs and wire routing line up perfectly with the compartment, and I really like the extra space this new compartment provides. I have multiple ideas of how to hold the compartment to the frame tabs, and will work on that shortly. I made the outside of the compartment as close as I could to the chainring, but I'm not sure if this will have to be adjusted later due to chain slap or a dropped chain. If it does come to that, the adjustment is a simple matter of making the cutouts deeper. Due to possible chain slap, I'm contemplating gluing a piece of sheet metal in the area where the chain might scrape the compartment. There's been a slight change of plans. My original plan was to glue a block inside the compartment that would line up with the frame tabs, then screw them together to hold the compartment in place. I've always been leery of this idea, but drew a blank on other ideas. With enough time though, I can usually come up with another idea, and I did. This idea originally started out using wood, but ended up with Kydex since I have so much of it left over from previous projects. I'll have to cut out some pieces in 2 different sizes. The Kydex is only 1/16 inch thick, so I'll need multiple pieces to get the thickness I need, but for this mounting idea, multiple layers should not cause a problem. I made this template to make it easier to align the slot and mounting hole in each set of Kydex pieces. The height and width of the template is the same as the square Kydex pieces. I'll tape the template and one set of the Kydex pieces together using 1-inch masking tape. The tape is meant to keep the pieces and template aligned so the slot and hole will be cut as accurately as possible. I'm using a block of wood held in place with a clamp to align the pieces in a direction perpendicular to the direction the tape is meant to align. With the Kydex and template aligned as accurately as possible, I'll first use a drill bit to drill the hole that will mount the Kydex pieces to the compartment as a set. I'm drilling the hole large enough to fit a nut and bolt I have, which will be used to hold the Kydex pieces together while I cut the slot. I don't really have anything to cut the slot through the template, so what I'll do is use a drill bit of the correct size and drill multiple holes that can be turned into a slot using the same drill bit. The slot will most likely turn out a bit crooked, but as long as I've drilled it to the same size as the slot in the template, it should fit over the frame tab. I'm going to use the Kydex pieces to help me mark where the hole has to be drilled in the compartment. I'll mount the compartment in the frame similar to how it would sit when permanently mounted. I'll then lay down one set of Kydex pieces, which when placed over the frame tab it's meant to fit over, will line up where the hole in the compartment has to be drilled. With the Kydex pieces in place, I can fit a drill bit into the hole in the Kydex, then rotate it within the hole, which will etch a mark into the compartment at the exact spot where a hole has to be drilled. Because the compartment has little space for doing any kind of drilling, I'll have to drill the hole using only the drill bit and no drill. By placing the tip of the drill bit into the etched mark, I can turn it and begin cutting through the compartment wall. It's slow going, but in about 5 minutes, the drill bit will cut through and leave a nice clean hole. I had picked up some barbed T-nuts, thinking the sharp point could poke into the fiberglass to hold it in place. After some thought, I decided to flatten the barb to avoid the possibility of it cracking the fiberglass. To help hold the T-nuts in place when I tighten down the bolts, I decided to glue each T-nut to the outside of the compartment. I don't plan on tightening the bolts a lot, so glue should be enough to hold the T-nuts securely. Also, because the bolts will only be slightly tight, I'll have to use blue Loctite on the threads to keep them from loosening but allow them to be removed with some effort. To confirm the mounting system works, and also to hold the T-nuts in place while the glue dries, I'm going to mount the compartment in place as it would be when in normal use. There's 3 sets of Kydex pieces to mount. The 2 on the bottom half of the compartment are pretty easy to screw in place, but the one on top is slightly tricky. For this one, I put the screw on the screwdriver, then put the Kydex pieces onto the screw, then lined up and screwed in everything to the T-nut all at once. Using Kydex, I made this additional compartment trim at the front to add stability for the cover. Kydex bends easily when heated very little with a torch, so bending it to this shape wasn't hard. To secure the battery, instead of strapping everything down like it was in the original compartment, I decided to pack everything in place like it was being shipped in a box. There's neoprene on the sides and bottom. I've still to pack more foam once I finalize the wiring and component layout. Temporarily, I'm using my usual number 10 by 3/4 inch panhead screws to hold the cover on. These screws were a last minute choice, but I selected it because it requires a smaller hole to drill than all of the other options I can use later. I can still drill a bigger hole for any of the other options. I'm glad that now my aftermarket battery is completely enclosed within my new DIY battery compartment. I still have some finish work to do on the compartment, but I can still start using it as is. I guess ongoing from this point will be the durability test. I don't ride the Jetson very often, but when I do, it's usually for longer rides that last maybe 3 or 4 hours. Leave any questions and comments you have in the comment section down below. That's all I have for now, and I'll catch you in the next video.